channel. In this video I am going to solve few more questions from physical science question paper Kset 2023. So before going to start, if you are new to my channel, please subscribe my channel for upcoming videos. So in the previous video I have solved some of the questions from Kset 2023 exam physics subject. So here I am going to solve the questions. So already you are familiar with the question paper, those who have given the exam this time. So here those who have the curiosity, they can just see the question paper here. So the question here, okay, this one I am going to solve. So the electric and magnetic field E and B corresponding to the scalar potential phi, that is z comma t is equal to 0, and vector potential A z as a function of z comma t is equal to tz I cap. So they have given here the scalar and vector potential. We have to find out E and B, electric and magnetic field. So here for this question, so here is the yes. So first what you have to do, first we can take the vector potential A z comma t. Okay, then just write down these two given potentials. Next what you have to do here, just as we know, E is equal to what? Electric field in terms of phi and A, scalar and vector potential, minus del psi minus dou A by dou t. So if we take the derivative of phi and A for electric field, this first term is going to be 0 and the second is what? Minus Iz. Then if E is equal to what? Electric field minus Iz. Then B is what? Curl of vector A. Okay, then if we take curl of the given potential vector A, that is going to be, you can write in terms of determinant. If you evaluate, just these two are 0, so you will get with respect to J here. Okay, so the answer for vector B is what? J cap T. So here for a given question, the correct option is option C. E is equal to minus Z I cap, B equal to T J cap. Okay, so here E is equal to minus I Z I cap, B is equal to J cap T. Then next one, the light passing from air to glass refractive index 1.5, the reflection coefficient and transmission coefficients are. So as we know, the equation for reflection and transmission coefficient. So here reflection coefficient is what? N1 minus N2 divided by N1 plus N2 to the power square. If we have the refractive index for a given glass, that is how much? 1.5. If we substitute, we will get the reflection 0.04%. Okay, then if it is 0.04, then what will be the transmission? It must be 0.96%. So 0.96 if we get, then total R plus T should be equal to 1. So that means here option reflection and transmission coefficient. Reflection is 0.04 and transmission is 0.09%. That means option B is correct. So the next, So here I'm going to solve few selected questions. So the next one is um, okay, this one we can see. So the density of 100 plane in a simple cubic lattice with the constant A 2.5 angstrom, lattice constant A is equal to 2.5 angstrom. Then what the we have to find out the density of this plane 100. So for this what we have to do first, what is density here? It is given by the interplanar spacing D divided by A, lattice constant. So D is what? 100. So interplanar spacing, if one for 100 the value is going to be what? A is equal to A, because B and C values are going to be 0. So the interplanar spacing is equal to A for 100 plane. Then density A by A cube it is, sorry. So density is what? D by A cube volume. So A cube is there. So 1 A by A cancel, 1 divided by A square. A square is what? 2.5 angstrom. So 2.5 if we square, the value is going to be ratio, that is 1.6 into 10 to the power 19 per meter square. Option 1.6 into 10 to the power 19 per meter square. So option, which one is correct here? First one. So the kinetic energy of a free particle at a corner of the first Brownian zone of a two-dimensional square lattice is larger than that of an electron at the midpoint of a side of 0 by factor b. The value of b is. So here the kinetic energy of a free particle at the corner and center of the Brownian zone in two-dimensional lattice is given by h cross divided by 2m into kx square plus ky square. Then what you have to do? Kx plus ky square you have to take here. Kx that is wave vector is given by pi divided by lattice constant square, pi by a square, pi by here a, the lattice constant is going to be same. So this is going to be what? H cross square divided by 2m 2 pi square a square. Then what you have to do? So energy of this at the corner, that is what kz you have to evaluate. So then you will get for kz in terms of this equation. Then take the ratio. This is going to be what? Is equal to b. Then if you take the ratio, you are going to get equal to b. B is equal to here 2 pi square is there, so it is pi square. So everything that get cancel and you are going to have the final answer b here. So here option B is equal to 2. Option B is correct. So the next one, the Fermi energy of two metals X and Y are 5 electron volt, 7 electron volt. Their debye temperature are 170 Kelvin and 340 Kelvin respectively. The molar specific heats of these metals at constant volume at low temperature can be written as. So we need to find molar specific heat of the metals at low temperature. So they have given here Fermi energy of two metals X and Y and debye temperature for those two metals. So here Okay, so just it is little bit the question here answer, just you can try to understand if it is not clear. um, Here the molar specific heat equation, first you should write down pi square Na Kb square divided by 2 EF Fermi energy. Then plus this whole equation you should write for a molar specific heat. Then what you have to do, the specific heat you can take it as gamma. It is inside the bracket term gamma T minus gamma T plus it is, so gamma T plus A T cube. Okay, after writing that, gamma is equal to what here? It is inversely proportional to Fermi energy. So here the term A is equal to, that must be inversely proportional to d by temperature Td cube. If we take here the ratio of gamma for metal A and B, if then it will be 7 divided by 5. Okay, and if we take the temperature ratio of the two metals, the ratio is going to be 340 divided by 170. If we evaluate it, we will get 2 to the power cube, that is 8. So option here 7 divided by 5 and that is equal to 8. Option A is correct here. Okay, so the question, it is looks like difficult, but the answer you can if you have the formula for molar specific heat, you can easily calculate. So the next question, silicon crystal contains 5 into 10 to the power 28 atoms per meter cube. In an n-type silicon sample, the donor concentration is 1 atom per 2.5 into 10 to the power 7 silicon atoms. Assuming that the electron effective mass is equal to the true mass, then temperature T at which Fermi level lies at the bottom of the conduction band is. So they have given the silicon crystal which contains the number of atoms, and then the donor concentration they have given, then the temperature T you have to calculate at Fermi level. So the concentration of electrons we can write here how much it is in silicon crystal. 5 into n is equal to what 5, you can take the ratio of number of atoms, silicon atom to the that is here the concentration, the donor concentration in is 1 atom per silicon, that is 2.5 into 10 to the power 7. If we take ratio of these two, we will get 2 into 10 to the power 21 per meter. Then again we have to take the ratio of the masses, and here we need to calculate temperature. So here is the equation for that, and energy, uh, the energy in terms of kb and kt we have for Fermi level. EF is equal to EI minus kBT ln n concentration divided by donor concentration. Then if n equal to C, then what we will have here, this temperature is going to be what if we calculate 0.56 Kelvin. So the answer is here 0.56. Here degree Celsius also they are given Kelvin, so 0.56 Kelvin is correct answer. So these questions are little bit difficult, but you have to practice, then only you can solve them. Given the tight binding dispersion relation E as a function of wave vector E naught plus capital A sin square Ka divided by 2, where E naught and A are constant. A is the lattice parameter. What is the group velocity of an electron at the second Brownian zone boundary? Okay, so the dispersion relation is given by, they have given here dispersion relation. Group velocity formula you should know. So Vg is equal to d omega by, in terms of frequency, angular frequency, divided by wave vector, d omega by dk. Okay, if we take the h cross to the numerator and denominator, just you will get this group velocity in terms of energy, dE by h cross dk. So just write down this equation and substitute value of the dispersion relation in this equation, group velocity. Once you take the do the differentiation, here sin square is there, so you have to take the differentiation. After differentiating, you will get here the equation in terms of sine and cos at the boundary of second Brownian zone. So as we know, first Brownian zone, second Brownian zone, wave vector is what? Plus or minus pi by 2a. If we substitute value of k here in this equation of for the group velocity that we have obtained, so if we substitute, we will get the answer here, plus pi by 2a. The answer is going to be 0. So 2 get cancelled. A sin pi is what? 0. Cos pi is not 0, but here sin pi is 0. That's why the answer is going to be 0. Here option A is correct. So the next one, the energy required to remove a pair of ions Na plus and Cl minus from sodium chloride is 2 electron volt. The number of Schottky imperfections present in sodium chloride crystal at 300 Kelvin. So these are nothing but what? The Schottky imperfection, nothing but defect. Schottky defect you have to find out for given sodium chloride at 300 Kelvin. So first what you have to do, you have to write down the given temperature and energy required to remove a pair of ions is how much? 2 electron volt. Therefore, using the expression n divided by capital N exponential E by 2 kb into T, Boltzmann constant into temperature. Exponential, if you take energy is what? 2 electron volt, and value of this constant, Boltzmann constant, you should write. Temperature they have given 300. If we take the exponential of this value, we will get 1.56 into 10 to the power minus 70. Then that means n is equal to this value. If we multiply with Avogadro number, we will have 9.42 into 10 to the power 6. Then the volume of 1 mole of the crystal is how much here? 26.83 centimeter cube. Then if we take ratio of this n by volume, we will have the Schottky imperfection. How much it is? 0.35 into 10 to the power 6 centimeter. So here first you should know the formula for Schottky defect. We have Frankel and Schottky. So once you know the formula, you can calculate the Schottky imperfection. So these are the few questions I have solved from the recent Kset 2023 exam. I hope this video is helpful. If it is helpful, please like, share and subscribe my channel. Thank you for watching.